Welcome to the playlist for Module 1A, which Module 1A is designed to give you kind of an introduction to cognitive psychology as a discipline. So these videos are going to be designed to review and also supplement some of the content that was found in your textbook. Okay, so in this first video, I am going to review the work of Francius Daunders. And Francius Daunders is credited to be one of the very first researchers who attempted to investigate something relevant to cognitive psychology. So he was really the first researcher to ever attempt to develop a science of the mind. Okay, so this video is going to talk about one of his most famous research studies investigating what he called mental chronometry. So mental chronometry is simply the science of figuring out how long it takes someone to make a decision. Okay, so let's talk more about Francius Daunders and his work with mental chronometry. So Francius Daunders was a Dutch ophthalmologist and professor of physiology. And he was quite widely respected for his knowledge about the physiology of the eye in particular. He wrote a lot of very influential texts in the world of medicine and so on. And in addition to all of his accolades as a physiologist, as your text says, 11 years before the founding of the first psychological laboratory in Germany, right, Daunders made the first formal attempt to scientifically study the mind. And what's particularly striking about Daunders' work is that the methodology that he developed is still widely or commonly practiced today by contemporary cognitive psychologists. So let's look closer at this methodology. Okay, so before we look at the methodology, it's important to realize that Daunders' objective was he was interested in determining how long it takes a person to make a decision. Okay, so he attempted to answer this question by taking a measure of what's called reaction time. So reaction time is simply how long it takes a person to react to or respond to the presentation of a stimulus, right? So how long it takes a person to react to the presentation of a stimulus. And he developed two measures of reaction time. The first one he called simple reaction time. And that required participants to push a button as rapidly as they could when they saw a light go on, right? So obviously this is a contemporary rendering of Daunders' first experiment. They didn't have computers in 1868, in case that's a surprise to you, but it was basically the same task, just in a different apparatus. So with the simple reaction time, participants simply had to press a light as soon as they saw the light go on, right? So as soon as they perceived the light, press the J key. That was the simple reaction time task. But there was also the choice reaction time task. So the second reaction time task, called the choice reaction time task, required participants to push one button when a light was illuminated on the left side of the screen and another button when it was illuminated on the right side of the screen. Right? So they would press J if they saw the light on the left and K if they saw the light on the right. So let's delve a little bit deeper into what's happening when participants are completing these reaction time tasks, right? So with the simple reaction time tasks, right, there's presentation of a stimulus, in this case a light, which leads to a mental response, which is perception of the light. And this perception of the light or mental response leads to a behavioral response, which is pressing a button, right? And the reaction time, which is shown by the dotted line, is the time between the presentation of that stimulus and the behavioral response. And similarly with the choice reaction time task, right? We have a presentation of a stimulus. In this case, the light flashes on the left side of the screen, and that stimulus leads to two different mental responses, right? So the first mental response is the participant perceives the light and or perceives the fact that the light is illuminated on the left, and then they decide, because the light is illuminated on the left side of the screen, which button they should push, right? So there's perception of the light, and then the decision as to which button to push. And then there's the behavioral response of pressing the J key. So how did Donders use this information to answer his question, which was, how long does it take someone to make a decision? Well, he simply subtracted the two, right? So the simple reaction time task, with the simple reaction time task, effectively what Donders was measuring is the amount of time it takes for individuals to perceive the presence of a light, right? So if the light was illuminated anywhere on the screen, they would press a computer key, right? So the simple reaction time task corresponded to the time required to simply perceive the stimulus of the light, right? Whereas the choice reaction time task, included that perception of the light, that same perception of the light, but it also included the amount of time it took to decide, based on the location of the light, which key to press, right? So in order to find out how long it took participants to complete this decision-making component or decide which key to press, he simply had to subtract the simple reaction time from the choice reaction time, right? Because the choice reaction time gives us the time it requires, or the time required to perceive the light and decide which key to push. And the simple reaction time gives us redundant information, which is the time to perceive the light, right? So if he wants to know how long it takes to make a decision, right, he simply subtracts the simple RT from the choice RT, and he's left with the time to make a decision by itself, right? And what he found was that it takes about 0.2 of a second to decide which key to press, right, for the choice reaction time task, and only about 0.1 of a second to perceive that a light has been illuminated, as in the simple reaction time task, right? So putting those into that equation, he concluded that it takes about 0.1 of a second to make a decision, right? So why does this matter? Why is this important for us? Well, it's important because this experiment revealed something very significant about the study of the mind, and that is that while we can't directly observe or measure mental responses, right? So we can't directly measure the mind perceiving a light or making a decision, we can make inferences about those mental responses on the basis of behavioral responses, right? So we can use, excuse me, we can use behavioral responses as a means of learning something about what's going on in the mind, right? So again, we can use behavioral responses, in this case, reaction times, to infer something about what's going on in the mind, even though it's a black box, right? Okay, so that concludes our discussion of Daunders' reaction time task. And real quick, I didn't say this earlier, but mental chronometry is just Daunders' name for the science of figuring out how long it takes someone to make a decision, right? So he gave himself or his pursuit kind of a fancy name, which is mental chronometry, or the science of figuring out how long it takes to make a decision. Okay, so that concludes our video on Francius Daunders. If you guys have any questions, feel free to reach out, and I will see you in our next video.